Morning to everyone, and that was Alanis Morissette. Is it one hand in my pocket? Hand in my pocket with Alanis Morissette. I've handed out a piece of paper to you that has some problems on it. Now, we're working on how much, and I thought we'd start with one of these problems. It just works our way through some of these. I've tried to get it to where some of you are having to share, but let's see what we can do. In particular, down here on the 7th problem, now let me set this up. We have a can of paint, and you're told in that can of paint it's used for making strips on highways, streets and such. And 1 quart will cover a 250-foot strip. Now, think of a paintbrush, maybe 4 inches wide, 6 inches wide, and you're just going to take that paintbrush, and here's what you're going to do. We're in Modesto, and we're going to start at 5 points. That's where McHenry, J Street becomes McHenry, depending on which way you're going. You're going to run a line 4 to 6 inches wide from there all the way out to Kiernan. Now that's when you're at Modesto city limits, basically. That's where you can, if you keep going, you're on your way to Escalon. So a single strip, roughly 4 to 6 inches wide, going from J and McHenry, 5 points, out to Kiernan. How many gallons of paint do you need? Let's go back to the problem. The argument is that's a 5-mile strip. 1 quart will cover 250 feet. You will need the equivalences from page 66 in your book. I'll leave that on the screen for a moment. And just a comment for tomorrow to put things in perspective. Okay, for tomorrow, I'd like you to have spent some time. Let's come off there now. Sorry about messing that up for you temporarily. Here is the set of equivalences, and I'd like you to have these pretty much memorized by tomorrow because you're going to need them on the test. And what I will do tomorrow is a quiz for extra credit for the exam, like we did for the formulas. So all of them. I mean, I'll only give 5, but of these lists here, here's what we're dealing with in this list of equivalents. That's what you need for this problem. Okay, so again, keep in mind that 1 quart will do 250 feet. You're doing a 5-mile strip of paint, 5 miles long. I want to know how many gallons. So as we come off there for a moment, that first group gave you part of what you need. And way down here near this portion, in this group, there's another one that you'll need. So that's a big hint. Okay, so you have something there and something from the beginning. And I'd like you to know all these equivalences. So tomorrow we'll have a brief quiz in that right at the beginning. So here again is the problem where we have this information. Okay, so the argument is that 1 quart will cover, or means that you can paint something 250 feet long, and you have a strip 5 miles long. Set it up. We'll see what you get. Just set that up for a moment, please. And we'll leave the problem on the document cam for a few more minutes. Well, we'll see. Let's see what we've got. Okay, let's go to the board now. At the beginning, I want to go ahead, and is that looking, what camera are we on? That's why we're going downhill so bad. Okay, that's okay. It's just I was wondering if I drew it that badly. I'm out of curiosity. We're at 10 and a half and 10 and a half, pretty close. So at this point, my first fraction, what should it be?
1 gallon.
I want gallons at the end, you should have written something with gallons on top. Now, from that list of equivalences, let's look at what we have. 4 quarts equals 1 gallon, correct? So we want the gallon in the top, so you should have 1 gallon over 4 quarts. Now, I'm using some abbreviation here. Okay. Now, once you've started, and this is the important first step. So right here, this is our first step, and you always have the units, the dimensions that you want in your answer on top. So always have units. I'm going to put dimensions here. Dimensions you want. In answer on the top. That's always your first step. So always have units or dimensions you want an answer on the top. Okay. Now with that question, what's the second step? Always. No, always. What guides you in the second step? Okay, whatever's in this first denominator always has to be in this numerator. So that's your second step. So second step, always have units, dimensions again, in first denominator in numerator, meaning top, of next fraction. Now that's what we've done. We've put quarts up there. So we're always have the units or dimensions in first denominator in numerator of next fraction. So that means it has to be quarts. Now, in the problem, otherwise I need to get something here that's going to give me something I can use. And there we go. That 1 quart will do what? Give me 250 feet. So as I come back to the board, I have 1 quart over 250 feet. Now, what are you expected to show at this point? That these two cancel. So cancel your dimensions. So the quarts and quarts cancel. That was the intent. But in my next fraction, what do I have to have? Again, this is the second step, and this just continues. So it's a second step, third step, and on. So second step and on. Sort of like to infinity and beyond. So second step and beyond. This has to be feet. Now, if I abbreviate feet up here and don't abbreviate it here, I hope you understand that they're the same dimensions. What can I now use from my table of equivalences coming all the way to the top? Let's go to the document cam. It's that first one, correct? Because I have miles that I have to deal with. So that means I'm going to use the 5,280 feet. And it looks like I'm going to need a little more space. So 5,280 feet over what? Over 1 mile. Okay, the feet cancel. This is your and beyond step, and what must be there? Miles. And do I know how many miles? 5 miles, and that's just over 1. That's it. They get fun if you get them. But they are very important problems in science, in mathematics, and whenever you have to use proportional thinking, this is a way out. Because doing this in your head can be very difficult. Now, what's your next step? Final step. So, last step. What do I do? Write your numbers. Write numbers. Cancel. Get answer. Remember, include units. What is your last step on this, Adrian, out of curiosity? Okay, you can multiply the numbers in both top and bottom and then divide. But it's, if you like the interesting part, let's slide over now. So we'll just slide over. Leave that in, okay, a thought there. Why don't you bring that back to where it was? I like that, Ernie. We maybe need to come back to it. That's a good idea. Okay, just a little more left justified. Just a tweak. The other way. Left justify. A little more. Keep edging till you get there. A little more. Come on. There. And now, with the other camera, give me space to the right, because we're going to come back to that. And so, if you bring the camera 2, are you in 2 now or 1? Oh, I didn't realize that. Can you give me camera 1 here, and then free up camera 2 for me? And then I can refer to this as we do our next step, because I'd like to come back and review the step-by-step procedure here. So what Ernie's going to do is give me the space to the right of that, and then I'll just slide over whenever he gives me a thumbs up with his banged up thumb. It is the thumb that's banged up, isn't it? Yes, a pinky. Okay, we'll slide over. Okay, that wasn't quite the way I thought we were doing that, but it'll do. And you have camera 1 where we can go back to that, is it right? Okay, so we have that. So I'll be over here. Next step, 1 times 1 times 5280 times 5 over 4, bad move, 4, that 4 was ridiculously bad, 250 and a 1 and a 1. And this is in what at the end? Must indicate the units. If not, you will be docked for your solution.
Do we have to write it right there? Can we do it with the answer?
No, you have to have it intermediate steps. I want to see the units also, just as a rule of thumb.
So after all done.
So after you're done, we'll go back to the first camera.
No, I mean after right there.
Go back. You have that first statement up here.
Uh-huh.
Then you're coming here. You're going to have gallons at that point. Now, depending on how you do this, you do have the option, if you want, of doing things like this. 5 into here once, into here what? 50 times. 10 into here 5, and 10 into here 528. Now that helps a little bit, because I could divide 20 into 528 at this point. Or, here's another solution I like. 4 times 250 is what? 4 times 250 is what? Otherwise, right now, I could write it as 428 over 20 gallons. But again, my question is, what is 4 times 250? That shouldn't be that hard.
132, he said.
I want 4 times 250. 4 times 250 is 1,000. So you could have done this. Now, why would I be interested in 1,000? Because it's 10 to the third, and whatever I get here, I can just move the decimal 3 places to the left. Right?
Sure.
What do you get when you take 5 times 5280? Okay, 2, 6, 4, 0, 0 over 10 to the third. So what is my answer? That's 26.4 gallons. Now, by the way, if you go to the local paint store and ask for 26.4 gallons, okay, so again, you're going to the store. So you would get 27 gallons, right? Yes.
How do you get 20?
Well, when I divided, the question was where did this 20 came from? I divided 5 into 250 and got 50. Then I divided 10 into these two and I got a 5. 5 times 4, 20. Now, just a comment. If you want 26.4 gallons and you have a car and you're going to put it in the back of the car, what's going to happen? Oh, you hope it's not going to spill. Although one of my neighbors had that happen. Do you realize how many gallons 27-gallon cans will be?
Couldn't you just get 4 or 5?
You aren't going to get, you're only going to get half that in your trunk, and then your trunk's going to do what? Well, the car is just going to go like that, okay, unless you have air shocks or something. Typical problem. That's what you have to be able to do, okay? So let me tell you the motivation in this problem. I lived in a townhouse for a while and was the president of the association, which meant you got to do some of the things that needed to be done that didn't get hired out. We needed to repaint the parking stripes in the parking lot. And I was using a paintbrush about 4 to 6 inches wide and painting by hand all the strips. And I cannot in my wildest dreams picture starting at 5 points and painting one strip all the way out to what? To Kiernan. Now, by the way, that's a double strip. So this just takes care of one of them. So you need the other strip. So that means 52.8, 53 gallons of paint. And I could ask you if it is $10 a gallon, how much would you pay? But we won't. You're welcome. Now we have an interesting period of time coming up called the holidays, right? It's going to go much too fast. But it's food time. That's a good way of stating it. We have Thanksgiving and we have Christmas and we have the Super Bowl time. And the idea is it's a time to do what? Enjoy, to celebrate, and to eat.
Open presents.
Okay, so let's take a little different problem here. We have 1 week here in October. That puts us to Halloween when you don't want the kids to eat all the candy.
I get all the chocolate.
So you do what? You help because you don't want them to eat all of it. And then you have 4 weeks in November, roughly, 4 weeks in December, and the first week of the new year, all celebratory, lots of things to eat. So let's say you gain 2 ounces per day. Only 2 ounces. Now, on a scale, 2 ounces is nothing. You won't see it, but it's per day. Okay, so the question, doing this problem, how many pounds that's LBS, pounds, or what? Okay, how many pounds will you gain in the 12 weeks?
I know you gain a pound in 4 days. Would be 18
No,
ounces a
no,
day.
no, 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 no. How many ounces in a pound?
16 ounces.
See, in 4 days, it's still just a half pound. Okay, so how many pounds will you gain in the 12 weeks? So these are the 12 weeks from now to the first of the new year. So this is a proactive problem to contribute to your health. during these days of celebration?
Gained 96 pounds, man.
No, you aren't going to gain 96 pounds. How are you going to set it up?
1 week, 7 days.
No, absolutely not. Ernie, camera 1 again. What is my first step? First step. Always have units you want in your answer on the top of the first fraction. So maybe I should put there of first fraction. So that means I want what? So if I come back here to the problem, my first part is going to be 1 pound.
Over 16 ounces.
Now, of course, the argument is I need to know what?
How many ounces?
An equivalence. So, 1 pound, 16 ounces. I'm going to use OZ for ounces.
Then times 2 ounces for 1 day.
Well, that's my first fraction. That was my first step. What should I do in the second step? So Ernie, at this point, could you in camera 1 now just pretty much focus on first, second, and maybe the second step there. Second step and beyond. So it's that next part that I want, second step and beyond. So if you'll go to that, I'd appreciate it. Okay, that's the second step and beyond. And it says, always have the units that were in the first denominator in the numerator top of your next fraction. Okay, let's go back to the other.
2 ounces of
So I'm going to have the 2 ounces, because that was what? Gain 2 ounces per day. I should finish that up. So that's 2 ounces over
1 day.
1 day. Now what should happen at this point?
Days should be the next.
No, but what happens to the ounces?
Oh, they cancel.
I can cancel the ounces and then put what in my next fraction?
Days.
This is back to the second step. First camera. It says that I want in the numerator the denominator of the fraction before it. So I do that and I'm at day.
7 days.
Now since I wanted weeks, I need to know something about days in the week. This is, now just keep in mind,
Over 1 week.
okay, but keep in mind there are times when you don't have 7 days in a week. A work week is 5 days, right?
So if it
So it depends on whether you're working or gaining weight or what's going on, whether you're doing it each day. Now, we're going to assume that 7 days of the week you're celebrating.
1 week.
1 week.
And then 12 weeks.
Stop, not yet.
16 weeks in.
Not yet.
No.
Next step,
Cancel days.
cancel your dimensions. So, okay, so now we're in our one more. Let's go back to that second step still.
Times 16 over.
No, I have 12 weeks
Or over 1.
over 1. So I'll move out of the way. And that is what I have to do. Now my next step, let's go back to the last step here, right here. Write numbers, cancel, get answer. Remember to include the units.
I may lose.
So let me write that. 1 times 2 times 7 times 12 over 16 LBSs. As LBSs, it doesn't sound so bad. So what are we going to do there? You can cancel, right? Multiply straight across, do that. Divide by 16. If you do, what do you get?
10.5 pounds. 10.
10 and a half pounds. And of course, that's time for the New Year's resolution, which is to lose. Let's just bring that down so you can pick up there and just talk about it while it's there. Your New Year's resolution, lose 2 ounces a day. How many weeks will it take to lose those 10 and a half pounds if you lose 2.5 ounces a day? The 12 weeks. So that means, I'll see, January's gone, February's gone, March is gone, and about in time for Easter, you could have Easter dinner. And the usual chocolate candy and such from the Easter basket. But, you know, that's only a couple days, and so things aren't too bad. And then you got the summer to have all those activities. So this is the contribution of dimensional analysis to weight control.
Or uncontrolled.
Okay, the problem that was written on the handout you have is stated this way. I decided to change it a little bit. An athlete decides to lose some weight, and of course does it in the same way. That is 2 ounces per day. Now that's the discouraging part. You're wanting to lose 2 ounces a day. You get on the scale. Nothing happens in the first day in the scale, nor the second day. Now, as Teresa was saying, you go up to about 4 days and you see a half-pound difference. But if your scale's not the kind that's all that accurate, you may not see anything for the first week.
You can make your scale lighter.
No, you can't make it lie to you.
Yeah, you could change it.
Well, hold on to the towel bar.
Right, hold on to the towel bar while you're weighing. The key here is you don't see these kinds of changes, either losing weight or gaining it on a daily basis. But if you get on the scale on a monthly basis, you see changes. It's rather interesting the way that happens. Well, let's see what we can do here. There are other problems that are a little bit frustrating. This is the one that I like. Okay, let's see what I can do here. This is, let me raise this up just a little bit more. Well, there we go. Now, this is, all of you have bought spices at the store, and they don't have a lot of weight to them. This is 1/8 of an ounce, 0.125 ounces, so it's not very much. But it sells for 85 cents. So you just have a small amount of pepper you're buying. If you had to pay that much for it, and by the way, you're paying for the container more than the pepper, how much are you going to pay for 2.5 pounds? So I want to know how many dollars for 2.5 pounds of pepper that sells in the store for 85 cents for 0.125 ounces. So I'll just let you, it's the same kind of problem. I'm going to go to another board. Okay, so we'll just go over there in a moment, but I want you to set it up. Keep in mind what you want in your answer. And the documentation is something I'm going to be concerned about as I look at the problem. Remember our rules. First fraction. I want to know how many dollars, that's what you don't see, how many dollars for a 2.5 pound can. And it's 85 cents for 0.125 ounces, and this is just a small container of pepper. So what are we going to have in our first fraction? $1 over what? Over 100 cents. That's my first step. Back to the front board, first step. Okay, back to the front board, first step, and that I need to back up to the left. That was second step, so slide over. First step, always have units or dimensions you want in the answer on the top of the first fraction. And as I come to the sideboard, that's what I've done. Back to the front board, second step. Always have the dimensions or units in the first denominator in the numerator or top of the next fraction. So that must be cents. Now I need something from the problem, so back to the document cam. 0.125. Whoops, didn't do that well. That's 85 cents. And the bottom is 0.125 OZ, right? So let's look at what we have on the board. So 85 cents, 0.125, and you can put the 0 there if you want. What should I do before I go to the next fraction? Cancel cents, make sure that the only thing I have left at the end is dollars. What must be in the next numerator? Let's go back to the front board, step 2. Step 2 in the front board still.
There's going to be,
I remember I want to have the units in the denominator. So I come back and look at this. And that goes in the numerator, back to front board. Goes to the numerator. So I have to have OZs here. Now, what was the problem about? Back to the document cam. Was how many dollars for what? Pounds. So I know I need something with what? Ounces and pounds. And my 16 OZ, ounces, or Oz, is going to give you 1 lb, 1 lubd for our pound. Do our ounces cancel? Yes. Now, one more fraction. This is my next step again. This is and beyond, so back to second step. So the second step is, again, remember the numerator has the old denominator on top. So I have to have an LB up here. So we come back to the sideboard. And back to the document cam. I have 2.5 pounds. So I put the 2.5 there, put a 1 here. Now the next step you don't have to do. I think it helps. And by the way, I need to cancel the pounds. Now let me write the numbers. 1 times 85 times 16 times 2.5, and that's over 100 times 0.125 times 1 times 1, and this is going to be what? Dollars.
so when we're doing the test, we have to put dollars in each step.
Well, I only have one step here, and then the next step is going to be my answer. So in that intermediate step, yes, dial for dollars. Okay, what does this all come out for those of you who've done it on your calculator?
2720?
I'm hearing 2720 with a question mark.
I got that too.
You got 2 instead of 2720?
I got that also. Well, then
Well, where does the decimal go? I heard it's 2720. Where do you want me to put the decimal?
I'm putting $27.27.
Okay, so $27.20.
Both guys got it right?
So 2 of you agree. Did anybody else agree?
Adrian got $2.
$2 for Adrian. I'll let you buy my pepper.
Yeah.
Okay, you're doing it as a bargain. Let's see if it makes sense. Let's see if we get some idea. 100 times 0.125 gives you what? 2 places to the right, 12.5, correct? So again, if you look at it that way, 100 times this is 12.5. Okay, so you have, let's put it 12.5 into here is a little more than 1. Okay, is that high enough? Well, it looks like we need to work with these numbers a little bit because I'm not getting anybody feeling very comfortable with the numbers. Let's see if we can get an estimate. Now, my argument is this is over 12.5, correct?
Okay.
You with me so far? Now, if you were just to make a rough estimate, wouldn't you argue that 25 goes into here about? 2.5 goes in here about 5, maybe? Huh?
Yeah.
Okay, what's 5 into 85? 17. 17 times 16 is only 27? You want to try again? It's not $27.20. It's what? $272. Oh, now we say I should have gone with my first. $272. Yes? What promoted much of the travel in Columbus's time?
Salt. Spices.
Spices. Salt, because you needed it for preserving things. And sometimes you needed pepper so you could what?
Spicy.
Disguise the taste when it was turning pretty rotten.
Didn't they use that to try to preserve stuff too?
Well, pepper, yeah, in the sense of we think of black pepper as opposed to cayenne sauce and things like that. Yes, you can use that to preserve. But because food storage was pretty difficult, they didn't have refrigerators. You needed salt and pepper, and so it promoted travel to find a place to get it. $272, folks, for a 2.5-pound can. I hope that's sobering. Okay? Now, let's leave that problem there. Let's see if we can find another one. And of course, what I don't finish, you're going to finish for tomorrow. So let me see if I can find another one.
I had the right answer. My decimal was in the wrong place.
Okay.
I'm always right, even when I'm
Always right, even when... Okay, we got to let that one go for you.
My head was spoiled.
Okay, this is an interesting one. Now, if you blink one time every 5 seconds. Now, if you're conscious of when you blink, it's hard not to blink. But if somebody's watching you and you blink one time every 5 seconds, the question is, and by the way, you blink when you're awake. So the question is, how many times do you blink in a week? And let's assume that you sleep 8 hours a day. Okay, you got the idea? So you blink one time every 5 seconds. You sleep 8 hours a day, and you blink when you're awake. How many blinks in a week? Got the idea? Set it up and let's see what you get. Okay, you want the number of times you blink. So how many blinks in a week? How many blinks? Set up the first fraction. We're waiting for, with camera 1, let's go back to the first step. We'll bounce back and forth between the first step and the problem. First step. You want your units in the answer on the top. Okay, so this is what we're after. We don't know how many times we have to write fractions, so we can just start. Okay, let's come to the sideboard. I want blinks, right? That sounds like something we not typically talk about, but blinks. How many blinks? So the question, what do we have in the problem in the document cam to guide us? Now that one time every 5 seconds says what? One blink in 5 seconds. There's your start. So I don't like the way the blinks are looking there. So let's see if I can get that a little bit larger. So a big blink. One blink per 5 seconds. What must go on the next second part? Back to the first camera. First camera on second step. And I gave it away when I asked for Ernie to go to the second step. Because we need seconds. Because the units in the first denominator, back to here, go in the next numerator. So I'm going to abbreviate and say SEC. Securities Exchange Commission. But anyway, I want a week, so what do I have to put here? What's my equivalence? It is. So how about 60 seconds, 1 minute? Now, what do I cancel? Seconds, then minutes in the next. And if we want weeks, 1 week, right? So I need number of minutes in an hour. 60 minutes in 1 hour. New fraction.
8 hours in 1 day.
Be careful. You're sleeping 8 hours. You're awake 16 hours. Be careful. Okay, let's go back to the problem. I don't know if I have it set up where you can see that yet in the document cam. Yes, you sleep 8. So you're awake 16 hours. 1 day. But this was for what? We're going to have to pan now to...
7 days, 1 day.
Okay, let's keep going over to the side. Pan over with me. And we're going to have 7 days over 1 week. And by the thing I didn't do, now I went too far from you, Ernie. I need just where I was there. Keep going. I want to see as much as I can. Okay. Now I have to cancel minutes and hours. And now I can do what? Cancel days. And then I'm going to multiply by what? As we just slide over just a smidge. 1 week. Now I could have asked for a month. Okay, that's a lot of numbers. So let's slide back to here, and maybe I can pick up the 1 blink. There we go. I have 1 times 60 times 60 times 16 times 7 times 1 over 5 times 1 times 1 times 1 times 1 times 1. And this is blinks. Okay, so fortunately, we can cancel the 5 if you wanted and say that'll go 12. And then all you have to do is multiply 60 times 12 times 16 times 7. Adrian, you said you have a number for me. 80,640 blinks. Now, if you wink at somebody every 5 seconds, you've winked at them 80,640 times in 1 week. You'll have Tourette's syndrome. Okay? Good point. Okay, let me leave that one on the board. Now, nobody really cares, I suspect, how many times you blink in a week. But think of it in terms, is there another way that does the answer any easier or any better than this dimensional analysis?
No.
And I don't think there is. This is a very powerful tool. Now you can sit and count the number of blinks for looking at somebody for 1 week, 16 hours a day. No. Even if you like the person, that's a lot of time to be looking. So at this point, what do you need to do for me tomorrow? Well, we're going to have a quiz tomorrow on the equivalences. So you need to look at this page again. Just a reminder, let's go back to this page of equivalence. This is page 66. There's a lot of them, but most of them are familiar. I'll just scroll upward for a while. This is like the credits at the end of a movie. And I ran out of space, and there's about 10, I guess maybe 8 more. And then, listen carefully, because I expect that you have been working on the problems in this unit. The test is Thursday. There are supplementary problems, and I want you to also work on some of the problems we didn't get done on the ones I handed out to you. If you're sharing it with somebody, maybe make a copy of it or something. I have one more I can share up here. So, Louis, I have one more. Just pass this to, there we go.
Oh, my bad.
Can you make it?
No.
No, he just managed to, okay.
I'll get it.
In addition to that, test on Thursday. That's going to be an hour test. The quiz tomorrow, which is Tuesday. And covering more problems. Wednesday, I will answer questions and give you yet another sheet of how much problems. The quiz grade will be added on to your test grade as extra credit. So I'll have 5 that I give you tomorrow. And something like this, I'll ask you, how many feet in a mile? And you will have to write something like 5,280 feet equals 1 mile. That's tomorrow. We'll do that probably either at the end or at the beginning of class. And then things like how many ounces in a pound, how many quarts in a gallon, that kind of thing. And I'll give you 5 of them. Let's see. Next would be a question of documentation. I just want you to remember. And Ernie, you still have, if you go to the first problem on that sideboard, I want to make this pretty clear. First problem on the sideboard, if you'll bring that in. Remember, this is how your solutions must look to get full credit on a problem in this unit. I have to have 3 steps minimum. The first step, then rewriting the numbers, and the answer with the units. I have to have that shown, or you don't get credit for your solution.